Okay, so in this video we're going to be working on the day 7 warm-up questions. Okay, so these questions have to do with the wave behaviors we talked about in the last unit. Okay, so question number 1 has 4 different parts, and it says, for each of the following observations, determine which wave phenomenon is responsible. So just to remind you, the wave behaviors we talked about are reflection, refraction, diffraction, and interference. Okay, and I will give you a hint. There's 4 questions, A, B, C, and D, and each of those 4 wave behaviors is used one time. Okay, so your answers to these questions should be one of those 4 wave behaviors with none of them repeating. Okay, so try to answer question 1A on your own. It says, a loud clap echoes in a canyon. So what wave behavior do you think that is? Okay, so obviously, well, hopefully obviously, an echo involves reflection. Okay, so if you've ever been to a canyon and you yell out, basically the sound wave that you emit hits something, reflects off of that something, and then comes back to you, and you can hear yourself echo in a canyon because of reflection. Okay, so that is going to be reflection. Now, 1b says waterways are bent as they pass through an opening in a rock. Okay, so see if you can figure out which wave behavior is responsible for that. Okay, so this is going to be diffraction. So remember, diffraction is the wave behavior. So let's say you have an opening in a rock like this. Let's say you have a wave that comes in like this. Okay, diffraction involves the spreading out of a wave after it goes past an opening or a boundary. Okay, so that is definitely going to be diffraction. 1C. The radio volume goes down when a car is stopped at a certain point, and it goes back up when the car is stopped at a different point. Now the hint for this is at one point the radio volume goes down, and at another point it goes back up. Okay, so think and see if you can answer that one on your own. What wave behavior is that? Okay, so this is going to be interference. Okay, now the reason this is interference is at some points you might be driving along and the car radio volume goes down, and the reason is at that specific point you might be getting destructive interference for a wide variety of reasons. But if you get destructive interference, there's going to be less of a radio wave where your car is, because there's going to be some cancellation, because that's how destructive interference works. Now, when the volume goes back up at a different point, you might have constructive interference there, where the two waves are combining it to form a bigger wave, and so the volume goes back up. Okay, so that is going to be interference. Okay, now 1D, there's only one remaining, so what is 1D? 1D says light from the sun is focused by a magnifying glass onto a blade of grass. Okay, so anything involving magnifying glasses or lenses or anything like that being focused is going to be refraction. That's the only wave behavior left. Now the reason it's refraction is because remember when any wave goes from one medium to another, but specifically a light wave goes from one medium to another, it bends. That's what refraction is. And by bending the light and focusing it, that's basically how things like eyeglasses work, or telescopes, or magnifying glasses, or microscopes, things like that. Okay, so that is going to be refraction. So hopefully you identify those 4 wave behaviors. Pause there if you need to look at that. And let's go on to question 2. Okay, question 2 says 2 wave pulses approach each other as shown in the picture below. State what type of interference will occur when these 2 wave pulses meet. This should be a very easy question. Okay, so while the 2 waves occupy the same location in space, you have superposition. What type of interference is this going to be? Okay, well, it's very, very obvious from the picture that this is definitely going to be constructive interference, because the 2 waves, when they meet, they're going to form a bigger wave, and that is the characteristic of constructive interference. Okay, so in the warm-up we had two hopefully pretty easy review questions related to wave behaviors. Please let me know if you have any questions, and I will see you guys in the next video.